volumes of prisms and cylinders. Alright, so we've got three shapes that we're going to be looking at for this lesson, and we're looking at finding their volume. Okay, so we've got some formulas to go with them. The first shape is a triangular prism. Notice that both its top and its bottom are triangles. We've got a rectangular prism. Its top and bottom are rectangles or squares. All right, and then we've got a cylinder, and its top and bottom are circles. Okay, these three shapes are similar in that their sides are straight, and their bases, the top and bottom, are both the same. Okay, we'll be looking at some figures, some three-dimensional solids next lesson and the lesson after that don't have that in common, but it's actually pretty nice when we've got that straight side. Okay, the reason is our formula is pretty simple. All we have to do to figure out the volume of these figures is to find the base, okay, and that's the big base. That's the area of the base, and multiply it by the height. Okay, you can think like for a cylinder, it's basically like taking a pancake and stacking it up and up and up and up and up, right? And depending on how high you go, you're going to have more pancakes, more area, okay, more volume. All right, so we've got our big formula that goes to all three of them, and then we've got the individual formulas down here to calculate what that big base is. Okay, and these should be pretty familiar. These are just how to calculate. This is the formula for a triangle, this is the formula for a rectangle, and this is the formula for a circle. Okay, finding those areas. All right, make sure you have all of these down because we're going to be using them a lot. All right, so now we're going to be finding the volume of these prisms and cylinders. Okay, we're going to use the formula, and our first job is to figure out the base. Okay, figure out the base of the shape that we're looking at. Okay, and the height, on a lot of these looks like it's larger than the base, but it doesn't have to be. Okay, this one actually has a larger base than it has a height, right? Kind of a short and squat box, and that's fine. So we're going to start with our formula. Remember our big formula. Our formula for all of these is the volume equals the big base, or the base, the area of the base, times the height of the figure. Okay? And then we're going to come down and we're going to say, all right, you know what, let's start with this one. We'll start with the easy one. Okay? So how I find my big base for a rectangular prism, looks like 13, is going to be the big base is equal to the length times the width. Okay, and I can combine that with my larger formula. Okay, because the big base is equal to length times width, I can just plug that in, and I can say the volume is equal to the length times the width times the height. All right, and that'll work. I could calculate the base and then multiply it by the height kind of separately. Either way, it doesn't matter. All right, you're going to get the same answer no matter what. But I like to combine them so I have one process to do the whole thing with. All right, and it lets me see where I need to plug in my values. Okay, so my height is 4. My width is 3. And my length is 6. Okay, and you can grab a calculator, and 4 times 3 should be 12, times 6 should be 72, and our volume for our rectangular prism here should be 72, and it should be 72, in this case, cubic meters. Okay, the meters might change, but if you're looking at a volume, it should always be cubic. All right, this can also be written as 72 meters cubed. Oh, rewrite that. 72 meters cubed, all right, with the exponent on the m. If you see it looking like this, that exponent is not on the 72. It's not on that value. Okay, it's only saying that we're looking at cubic meters, so we're looking at a volume. All right, now onto the triangular solid. This one is really similar to the rectangular solid, except it's half as large, right? It's as if we took this one and we cut right down there and we got rid of this part. Okay, got rid of all of this, and we just had a triangular area left, or triangular volume. Okay, so that's what we're going to be doing. We're going to be doing the same process as this one, except we're going to cut it in half. And if you remember, the area for our triangular prism, okay, overall is still going to be the volume equals the big base times the height, but for our triangle, it's 1/2 the base times the height, which is basically 1/2 length times width. Okay, so we're going to do that. We're going to do our big base is equal to 1/2 length times width, or base times height. Okay, little base times a little height. All right, and then I think I'll do it in two separate formulas this time, so we can look at it both ways. So I'm going to plug in my base and my height. It doesn't actually matter which is my base and my height here, but if we had a triangle or a triangular, let's see. If we look at this one, our triangular prism here, this side length right here is not the height, okay? And we're talking about the height of just this base, right? The side length is not the height. The height would be directly from the top all the way down, like the top corner, down to the base, okay? So make sure if you're looking at, if you have a problem and you're given two of the sides, it's got to be a right angle in order for this length to be the height. Okay. All right. So now we'll plug them in. We've got the height is 5. The base is 4.5. 4.5. And then we got 1/2 times 4.5 times 5. Calculator. Got 5 times 0.5 times 0.5, 11.25. So 11.25 is my base area, right? So that's going to be 11.25 square, in this case centimeters. Okay, and it's square because it's an area. Now, I'm going to take that, that's my big base, and all I have to do is multiply it by my big height. Okay, the height of my total pyramid, or prism, sorry. So that's going to be 11.25 times 8, would be 90. Alright, so this was my volume is equal to my big base, which I found was 11.25 times my height, which was 8, and that's going to equal 90. Okay, and again that's going to be 90 cubic centimeters. All right, on to our cylinder. Let's go ahead and get some more room. Okay, so now cylinder. Hopefully we all remember our circle work that we've just done. So we know that the area of a circle is equal to pi r squared, and we know our diameter, right? Our diameter is equal to twice our radius. So if our diameter equals 10, our radius is going to equal 5. Okay, I can plug that in. Area is equal to 5 squared. I don't need my calculator for that. 5 squared, would be 25 times pi. And I'm going to leave it there. I'm going to leave that as 25 pi for right now. Okay, I'm going to finish with the rest of my problem. Okay, I'm going to come back up now that I've got my big base. Right, the area is equal to the big base. Excuse me. And I'm going to bring it back down into my larger formula. So the volume is going to be equal to pi times 25, or 25 pi, times my big height, which is 21. Okay. 25 times 21 is equal to 525. So the volume is equal to 525 pi. And if they want the answer as a decimal to the nearest tenth, I just come back and say times 3.14, and I get 1,648.5. So the volume is either going to be 525 or 1,648.5. And really, I should be not saying it's equal to, but it is about equal to, right? Because that is an estimate.